I will be going over experiment 6, order of reactions of potassium permanganate and oxalic acid. The experiment starts with us dispensing 5 milliliters of oxalic acid into a test tube. Then adding 6 milliliters of distilled water with a different burette and a stirring rod. Then we add 1 milliliter of potassium permanganate and start a stopwatch. We can stop the timer as soon as the red color of the permanganate disappears. We recorded that our first trial took 350 seconds. Next, we will be calculating the molarity of oxalic acid. We start with the 5 milliliters of oxalic acid and divide that by the total volume of the reactants, which is 12 milliliters. And we multiply that by the initial molarity of oxalic acid, which is 0.755, which gives us 0.315 molarity. To calculate the molarity of the permanganate, we divide the 1.0 milliliters of permanganate by 12 milliliters, and we multiply that by the initial molarity, which gives us 0.0108. To calculate the rate of the reaction, we find the difference in the molarity and we multiply that by -1, and we divide that by the average time that the experiment took, which gave us 3.49 times 10 to the -4th molarity over seconds. Part B of today's experiment asks us to have the oxalic acid and the water in one test tube and the potassium permanganate in another test tube. I have created a hot water bath that is 10 degrees Celsius higher than room temperature, and I will be placing both test tubes inside the beaker. After 10 minutes, I will transfer the oxalic acid contents into the potassium permanganate and start a stopwatch. I will stop the timer as soon as the red color disappears to give a yellow color. After 3 trials, we discovered that the average time that the reaction took was 245 seconds in experiment 4. From there, we can calculate the rate of the reaction. By calculating the difference in the molarity and multiplying that by -1 and dividing that by the 245 seconds, it gives us the rate of the reaction, which was 4.87 times 10 to the -4th molarity over seconds.